Hi, welcome back to Check UL channel. Okay, in previous class we have covered 3 laws of indices. Okay, now we continue. Okay, for this one, how do you use law of indices to perform operation of multiplication and division? In previous class we have covered the multiplication and division of indices. Okay, now look at example 10. Okay, right, simplify each of the following. Alright, okay, now for question A, okay, given the question is 7 to the power of 3 multiplied by 5 to the power of 4 power of 3. Okay, so how you can simplify this is by, okay, open the bracket. Okay, look at this example. This power, okay, outside the bracket must multiply, okay, with the other indices in the bracket. So here, okay, how to solve this one is 7 will be power of 3 times 3 multiplied by 5 to the power of 4 multiplied by 3. So the answer here is 7 to the power of 9 times 5 to the power of 12. So this one is the answer, because this question asks you to simplify, so no need to find the value. Okay, for the question B, 2 to the power of 4 times 5 power of 3 times 10 power of 2 close the bracket power of 5. So how you simplify here is will be 2 to the power of 20, because 4 times 5, and then multiplied by 5 to the power of 15 times 11 to the power of 10. Okay, alright, now I will show you on how to simplify if it involves division. Okay, now we move to question E. Okay, question E, in bracket 2 to the power of 5 over 3 to the power of 2 close the bracket to the power of 4. So this one, it will be 2 to the power of 20 over 3 to the power of 8. Okay, all the index inside the bracket must be multiplied by index outside the bracket. Okay, we try another question. Okay, now I choose question G. Okay, so this one, how to simplify this? Okay, it will be, okay, 3 to the power of 3 m to the power of 6 n, okay, n to the power of 9 over 6 to the power of m power of 3 n. Okay, now you have to simplify this one. So how to simplify it? Okay, it will be, okay, 3 to the power of 3 and then m to the power of 6 minus 3, because, okay, at the denominator you have m power of 3. Okay, and then n to the power of 9 minus 1, because n is power of 1. Okay, over, okay, now we want to simplify, so we separate 2 and 3. Okay, 2 times 3 is 6. Okay, because now we can simplify here. Okay, this one 3 power of 1. So what happened here is 3 to the power of 3 minus 1, m to the power of 3 and power of 8 over 2. Okay, so the answer is, okay, I continue here because does not have enough space. So 3 to the power of 2 m to the power of 3 and power of 8 over 2. So this one is the simplest form for this question. Okay, alright. Okay, now we continue to brainstorming 4. How do you verify a power of 0 equals to 1 and a to the power of negative n is equals to 1 over a to the power of n, where a cannot be 0. Okay, now the aim for this brainstorming 4 is to determine the value of number or algebraic term with a 0 index. So kita nak tengok sama ada betul ataupun tidak a power of 0 is equals to 1. Dan satu lagi kita nak tengok a to the power of negative n, is it equals to 1 over a to the power of n. Okay, now we look at brainstorming 4 first to determine the value of numbers or algebraic term with a 0 index. Okay, now study and complete the following table. Based on this table, you look at this one, 2 to the power of 3 divided by 2 to the power of 3. When you use the concept of law of indices, 2 power of 3 when it divide, okay, when it have same base and then it divide, involve division, we have to subtract its index. So it will get 2 to the power of 0. If we use the repeated multiplication, we will get this answer. Okay, because this one, 2 divided by 2 is 1, 2 divided by 2 is 1, 2 divided by 2 is 1. So answer is 1. Therefore, the conclusion we can make here, when 2 to the power of 3 divided by 2 to the power of 3, we get 2 power of 0. Therefore, 2 power of 0 is equals to 1. Now look at another example. Okay, this one is actually B. Alright, m power of n, m power of, okay, m power of 5 divided by m power of 5. When we use the law of indices, we'll get m power of 0. And when we use the repeated multiplication, we will get 1. Therefore, the conclusion that we can make here is m power of 0 is equals to 1. Now, try this one. 5 power of 4 divided by 5 power of 4 is 5 to the power of 4 minus 4. So, this answer is 5 power of 0. When we use the repeated multiplication, when we simplify this one, we will get 1. Therefore, the conclusion here from the solution is 5 power of 0 is equals to 1. Okay, so based on brainstorming 4, this is found that 2 power of 0 equals to 1. M power of 0 is equals to 1. Therefore, a number or algebraic term with 0 index will give a value of 1. Means that any number that power of 0 is equals to 1. Okay, so this one is the conclusion that we can make based on the brainstorming 4. So we have verified that when a power of 0 is equals to 1, any number power of 0 is equals to 1. And a cannot be 0. Why a cannot be 0? Because if a is 0, so 0 power of 0 is 0. Okay, so any other number, okay, when it is power of 0, the value is 1. Now we want to verify about this one. Okay, let's discuss this one. Okay, based on this table, look at, based on this table, you have 2 to the power of 3 divided by 2 to the power of 5. When we use the law of indices, okay, we will get 2 to the power of negative 2. And if we use the repeated multiplication, we will get this answer. Okay, which is 1 over 2 power of 2. Because this one we can simplify here. Okay, and then we simplify this one, then we simplify this one. So we only have here 2 times 2, which is 2 power of 2. 1 over 2 power of 2. Okay, so the conclusion that we can make here is 2 to the power of negative 2 is equals to 1 over 2 power of 2. Now look at example B. M power of 2 divided by m power of 5. And we'll get, if we use the law of indices, we will get m power of negative 3. And if we use the repeated multiplication, we'll get 1 over m power of 3. So this one is the conclusion. Okay, now we try for C. 3 power of 2 minus 6 is equals to 3 power of negative 4. If we use the repeated multiplication, 3 times 3 over 3 times 3 times 3 times 3 times 3 times 3. Okay, it repeats 6 times. Okay, and then we simplify. Okay, and here we have 1 over 3 to the power of 1, 2, 3, 4. 3 power of 4. So based on this one, okay, the conclusion from the solution, we get 3 to the power of negative 4. Okay, 3 to the power of negative 4 is equals to 1 over 3 power of 4. So, okay, based on this brainstorming 5, it is found that, okay, 2 to the power of negative 2 is equals to 1 over 2 power of 2. We have verified that when, okay, a to the power of negative n is equals to 1 over a power of n. Okay, and value a cannot be 0. If a is 0, so we'll get undefined. Okay, now look at this example 11. State each of the following terms in positive index. Okay, so how to write it in positive index? It will be 1 over a power of 2. This one, 1 over x power of 4. Okay, why we get this answer? Because it is based on this law. Okay. Okay, what about C? Okay, now 8 power of negative 5 is at the denominator. So when we write it in positive index, it will be 8 to the power of 5. Okay. Okay, now refer to D. This one will be y power of 9. Here, okay, the negative index is for m. So negative index sahaja yang kita turunkan ke bawah untuk pastikan kita dapat positive index. 2 is remain as at the top or as the numerator, and then m is to the power of 3. Okay, what about this one? Okay, this one is, okay, 3 over 5 n power of 8. Okay, alright, this one, if we write in terms of positive index, it will be reciprocal. Okay, actually, okay, this, when we open the bracket, this one is the answer. Okay, and we write it in positive index, it will be 3 to the power of 10 over 2 to the power of 10. In other words, we will get 3 over 2. We reciprocal the fraction. Okay, then power of 10, positive 10. Okay, same goes to this one. We reciprocal y over x to the power of 7. Okay, now we look at question 2. State each of the following in negative index form. Okay, you just bring up the positive index, so it will be, okay, 3 to the power of negative 4. Here is m power of negative 5. Okay, for question E, okay, we reciprocal the fraction 5 over 4 to the power of negative 8. Okay, so now we continue with example 3. Simplify each of the following. Now we have to use the law of indices that we have learned. Okay, for question A, so the answer is 3 power of 2. Multiply, we know that we have to add the index, and when we divide we have to minus the index. So the answer is 3 to the power of negative 2. And normally we have to write it in positive index, so we give the answer 1 over 3 power of 2. Okay, and then question B. Okay, how to solve it? 2 power of 4, this one must we have to multiply the index, so 2 power of 8 times 3 power of 15 over 2 power of 16, because 8 times 2 times 3 power of 12. Okay, now we simplified it. 2 power of 8 minus 16 times 3 power of 15 minus 12. Alright, so the same base we can use the law of indices to simplify it. Okay, so this one will be 2 to the power of negative 8 times 3 to the power of 3. And your answer must be in positive index. Therefore, the answer is 3 power of 3 over 2 power of 8. Okay? Alright, next, I want you to try for example 3C. Alright, now we continue with the other learning standard to determine and state the relationship between fractional indices and roots and powers. Okay? Okay, now we want to look at the relationship between nth root of a and a to the power of 1 over n. Now we have fraction index. Okay, fractional indices. Okay, in form 1 you have learned about square roots as well as cube and cube root. Okay, now determine the value of x based on this one. Alright, given x squared equals to 9. Now we want to know the value of x. What we do is, okay, we will, okay, use square root of, so that this square will disappear. Okay, alright, so square root are used to eliminate the square. So the answer is x equals to 3. Okay. Same goes to this example, x cubed equals to 64. And okay, when we want to know the value of x, okay, we will find it by find the cube root of 64. Okay, so we get x equals to 4. So cube roots are used to eliminate cubes. Do you know that the value of x in example A and B above can be determined by raising the index to the power of its reciprocal? What it means by reciprocal is this one. 1 over A is the reciprocal of A. Alright, or other example, 2, okay, the reciprocal of 2 is 1 over 2, because 2 is 2 over 1. So with the reciprocal of 2 over 1 is 1 over 2. Look at this example. X to the power of 2 equals to 9. Okay, so x power of 2 times 1 over 2, because we want to simplify this one. Okay, then we will get 9. Okay, 9 to the power of 1 over 2. Okay, 9 can be written as 3 square. Okay, then we can simplify the power. Okay, alright, so from the above methods, okay, to determine the value of x in the example above, is found that Okay, we found that this one, square root of x is equals to x power of 1 over 2, and cube root of x is equals to x power of 1 over 3. Okay, so what we can make conclusion here is, okay, nth root of a, okay, is equals to a to the power of 1 over n. Okay, this one is the another law of indices. Okay, now we look at example 12. Convert each of the following terms in the form of a to the power of 1 over n. Okay, number 1, a. Okay, 36 power of 1 over 2. Okay, so the answer is 36 power of 1 over 2. Okay, this question just asks you to convert. Okay, and then b, cube root of negative 27 is equals to negative 27 to the power of 1 over 3. Okay, for question 2, convert each of the following terms in form of nth root of a. So, for question 2, a, 125 to the power of 1 over 5 can be written as fifth roots. Okay, fifth roots of 125. Okay, for b, 256 to the power of 1 over 8 can be written of 8 roots of 256. For question number 3, the question asks you to calculate the value. Okay, when you want to calculate the value for this topic, okay, when it involves indices, you cannot use calculator. Okay, I repeat, you cannot use calculator. Alright, now I take question 3a. Okay, fifth roots of negative 32. So you have to, okay, convert this one, negative 32 to the power of 1 over 5. Okay, you have to think what is the root of negative 32. Okay, so here it is negative 2 to the power of 5. Okay, negative 2 to the power of 5 to the power of 1 over 5. So this one we can simplify 5. So the answer is a negative 2. Okay, you get it? Okay, we tried other example. Question 3b. What is the value? Okay, so first we have to convert it in index form. Okay, 1 over 6 to the power of 1 over 6. Make sure you write it the index properly, 1 over 6. Okay, so here you have to think what is the value. Okay, what is the value when it's power of 6? So it will get 729. Is it? I think it is 3 power of 6, power of 1 over 6. Okay, I check with my calculator. Okay, 3 to the power of 6 equals to 729. So it's correct. Okay, so 3 power of 6 we will get 729. Then this one you can simplify. So the answer is 3. Okay, so you can try for other example, question 3c and 3d. Right, now we continue to look at what is the relationship between all this one, a to the power of m over n, and then a to the power of m in bracket to the power of 1 over n in bracket a to the power of 1 over n close the bracket power of m, and roots of a to the power of m, and in bracket n roots of a close the bracket power of m. Okay, actually all this form, okay, will derive same value. Alright, you have learned this one. A to the power of mn is equals to this one, and here n roots of a is can be written in the form of a to the power of 1 over n. Alright, now to show you, okay, the relationship between all this form, okay, I will copy back. I will refer to B, example B in this table. Okay, it is 16 to the power of 3 over 4. Okay, if we write in this form, okay, we write in this form a to the power of m, close the bracket, to the power of 1 over n. Okay, 16, okay, 16 to the power of 3. Okay, we take it this numerator, okay, because 3 times 1 over 4 we get 3 over 4. Alright, and then close the bracket, to the power of 1 over 4. Alright, then equals to 16 to the power of 3. 16 to the power of 3 is equals to 4096 to the power of 1 over 4. If we write 4096, okay, in power of forms, okay, we want to simplify this one. We want to simplify with this one, 1 over 4. So we have to find what number when to the power of 4 we will get 4096. Okay, so I use calculator, okay, to find it. Okay, and roots, so this one is 4 and then 4096, and the answer is 8. So 8 to the power of 4 multiplied, for 8 to the power of 4 we get this one, 4096, 8 to the power of 4. Alright, and then we multiply with the power of 1 over 4. Now what we can do is we can simplify this 4. So answer is 8. Okay, answer is 8. Alright, now, okay, if 16 to the power of 3 over 4 we write in this form, okay, 16 to the power of, in bracket, we take it 1 over 4 to the power of 3. Okay, this one will be equals to, now we look at what number, okay, what number when power of 4 we get 16, because we want to simplify this one, 1 over 4. Okay, so the value is 2 to the power of 4. 2 to the power of 4, we try to check it. Yeah, we'll get 16. 2 to the power of 4. And then this one must multiply with 1 over 4 and then to the power of 3. Okay, this one multiplied by this one. Okay, alright, so this one we can simplify. Okay, the remaining is to the power of 3. So 2 to the power of 3. What is the answer? What is the value for 2 to the power of 3? Okay, 2 times 2 times 2 is 8. We get the same answer. Okay, we get the same answer here. The value is same. Alright, now we try to another one. Okay, in the form of nth roots. Okay, so we know that 16 to the power of 3, okay, if we write in this form, okay, nth root is the fourth roots of 16 cube. Okay, 16 cube. So we find 16 cube, just now we have find it. Okay, 16 cube is 4096. So fourth root, okay, just now we have calculate fourth root of 4096 is 8. Okay, we still get the same answer. Okay, we get value 8. The last one, if we write in this form, okay, in terms of, in bracket, okay, 4 roots of 16, in bracket, close the bracket, to the power of 3. So 4 roots of 16 is 2. 2 to the power of 3 is 8. We get the same answer. Alright, so the conclusion here that we can make is this one. Okay, this one. So all these forms derive the same value. Okay, take note for this one. All these forms derive the same value. Alright, now look at example 13. Okay. Alright, example 13, number 1A. Okay, 1A. Convert. The question asks you to convert each of the following into the form of this form and this form. So we write it as 81 to the power of 3 over 2. 3 over 2. Alright. So how to write it in this form is, right, just convert. This one does not ask you to find the value. You just convert in terms of this form. A to the power of m, close the bracket, to the power of 1 over n. So the answer is 81 to the power of 3. You take the numerator. Okay, close the bracket, to the power of 1 over 2. Make sure you write it correctly. Don't write as this one. Don't write as this one. Okay, and you close the bracket, 1 over 2. Okay, 1 over 2 must be right correctly. Alright, to the power of 1 over 2. Alright, so this one is the answer, because the question just asks you to convert. Alright, next, B, 1B, 27 to the power of 2 over 3, it is equals to, in bracket, 27 to the power of 2. Close the bracket, to the power of 1 over 3. Alright, then you can try for question C. Now look at how to convert in this form. It is actually the same one. Okay, alright. So 81 to the power of 3 over 2. When you convert to this form, it will be in bracket, you take 81 to the power of 1 over 2. And then close the bracket, power of 3. Okay, if for B, 27 to the power of 2 over 3. Okay, so in the bracket is 27 to the power of 1 over 3 to the power of 2. Okay, just convert it. Alright, okay. If we try for question 2, this one you have to convert in the form of nth roots. Okay, so question 2, A, 343 to the power of 2 over 3. It can be written in the form, okay, nth root. Nth root, so you take the denominator. So this one is cube root of 343 to the power of 2. Okay, alright, for question B, 2B, 4096 to the power of 5 over 6. If we write in the form nth roots, so nth root, it will be 6th root. Okay, write 6, just small 6, don't large 6, because that one will give another meaning. Alright, okay, so this one is 4096 to the power of 5. Okay, what about if we write in this form? Okay, nth root, and then to the in the bracket, and then close the bracket, power of m. It will be 233 to the power of 2 over 3 is equals to, in bracket, nth root. Nth root is cube root, 343. Close the bracket, power of 2. For this one, 4096 to the power of 5 over 6 is equals to, open the bracket, 6 roots of 4096, close the bracket, to the power of 5. Okay.